Hi everyone, this is again Dr. Muhammad Irfan. Today we are going to learn some new techniques in descriptive analysis. In descriptive analysis, we will learn how we can rename the variables, select variables, and create a new variable using mutate function. Then we will construct crosstabs, use chi-square test and Ttest, ANOVA, and then at the end we will learn how to use Pearson correlation test and what are the purposes of all these tests. Okay, so let's open your RStudio. Open your script window. So let me close this one. So first of all, set working directory, and then also load two packages. One is dplyr and the other one is idlog. Probably need these two packages for data wrangling. And then, so RStudio comes with built-in data sets. I'm going to use the mtcars dataset for today's exercise. So just run this one, data in the bracket in the inverted commas mtcars by hitting Control Enter. So when I run this command, I can see my environment window is there. By clicking on this one, now I am able to see the data. So it contains 32 observations of and 11 variables. If you are not sure about the variables and if you want to see the detail of the variable, for example, this one is CYL. If you are not sure what is CYL, what is DISP, what is SP, TRAD, WT, QSEC, VS, AM, you can simply go back over there into your script window, go to your console window and write question mark, then say mtcars, enter. So once you say mtcars, question mark mtcars, then it will open a documents for mtcars data. Over here you can see the variables and then its explanation. For example, mpg is miles per gallon, then cylinder is number of cylinders, disp is displacement, HP is gross horsepower, and similarly DAT, WT, QSEC, VS, and AM. So here is the explanation of every variable. So for example, I don't want all the variables. I want to work on only few variables. So I want to select some variables from mtcars data. So what I'm trying to do is, for this is CS data is the name of my new data set, and I want to select the variables mpg, cylinder, HP, WT, AM, and gear from mtcars data. So this is the name of the data set I want to make. You can name it whatever you want, whatever you like, and then use select command, and then this is the data you want to take variables from mtcars, and then these are the name of the variables. Remember, the name of the variables should be exactly the same that you have in your data. All right, run this command. See, now I have another CS data in my environment window, and there are 6 variables. If you want to see how to select and drop variables in detail, please watch my earlier videos. And over there, I have also explained how to set working directory, how to open data. Okay. One more thing. I know that AM is transmission by documents. If I look at the documents over here in the 4th window, AM is a transmission where 0 means automatic and 1 means manual. So rather than saying AM, it could be a little bit difficult for you, for me to understand what AM is. So I just want to change the name of the variable from AM to transmission. So here is the command for changing the variable name. So CS data is the name of the data I want to save in. I want to use the same data set, this CS data, and then rename the command in the bracket CS data the data I want to change the name in, comma, trans is the name, new variable name, and AM is an old variable name. So you should remember, you should put it in the inverted commas. And then, so first look at this one. First look at the data. So it says it is the name of this variable is AM. I want to change this one to trans. So let's change this one to trans, and by running this command, I hit Control Enter, and now I can see that if I look at over here, see the AM is changed to trans variable. The name of the variable is changed. Okay. Okay, so one more thing is, before I forget, let me bring from down there. So it's possible that I also forget about what is 0 and what is 1. So I know that 0 is automatic and 1 is manual. So what I do, I want to change these zeros to automatic and 1 to manual. Okay, in the trans variable, I want to change 0 to automatic and 1 to manual. So how do I do that? Here is again the CS data is the name of the command, the name of the data, sorry, you want to save in. Mutate is the function you are calling it. Mutate, and then CS data is the name of the data. This data, trans, I want to keep the same name to make the changes in the same variables. If I want to create a new variable, then I have to change the name of these variables. If I don't change this name, then the recoding will happen in the same column. Okay, so let's see what it happens. Then trans is the name of the variables. It's equal to recode trans. Recode trans here is 1, so 0 to auto, and then 1 to manual. 0 to auto and 1 to manual. Here is the old data, 0 to auto and 1 to manual. This is what I want to change. So let's run this command by hitting Control Enter. And now let's see what happens. See, the trans is now manual, auto, manual, auto. Okay, so this is how you can change the values in one column and change the name of the variables. Okay, so first of all, whenever you start doing the data analysis or descriptive analysis, first of all, you should look at the data. The best way to look at the data is str CS data. It shows you the structure of the data. STR stands for structure. So you want to see the structure of the data, and it says it has NPG, CYL, HP, WT, trans, and gear variables. Okay, so all of these variables are numeric except trans, because I just have changed trans to a character variable. Okay, so if you want to see how many cars have different gears, so the best way to do that is to see table and then in the bracket CS data $gear. When you put dollar, it calls for the variable. Then you can select it from the variable. For example, if I put dollar, see the list of the variable is open. So I want to select gear. Is inside the gear. Okay, so now I see there is 3 categories of gear. One is 3, 4, and 5. Categories, 3 gears cars are 15, 4 gears cars are 12, 5 gears cars are 5. What if I want to see the percentage of these things? Simply just copy the above command and apply this pipe operator or then operator, and you write this one prop.table. This is a shortcut to write this command, the write pipe command. So you can use shift plus control plus M. If you use this one, then this sign will automatically appear. This is a shortcut for making this sign. All right, so once you run this command, so you will get the percentages as well. So 3 gear cars are 46%, 4 gear cars are 37%, and 5 gear cars are 15% roughly. Okay, and what about if you want to see the other variables? You can see the same. You can use the same command like table, and then for second and third command. For example, if you want to see the transmission, how many autos and how many manual cars are there, simply use table, and then CS data $trans, and see auto are 19 car and manual are 13 cars. Okay, so you can change also change the class of the variables. So we already know by our str command that the trans is character variable, gear is a numeric variable, and cylinder is also a numeric variable. But in fact, they are factor variables. So they have three categories. Cylinder and gear has 3 categories. If you are not sure and you want to see the cylinder variable, just write table, then CS data $cylinder. See, so there are 3 categories of cylinders. So 4 cylinder cars are 11, 6 cylinder cars are 7, 8 cylinder cars are 14. Okay, so how do you change these variables to factor variables? So the command is simple. What you need to do is the same, write the name of the variable CS data $trans, and then use as.factor, and in the bracket the same variable again, CS data .trans. Okay, so just run this command, control enter. The next, similarly with CYL, control enter. Similarly with gear, control enter. Now if you want to check the gear class, it will tell you it's a factor class. Why I do it? Because these are factor variables. Originally these are factor variables, and R doesn't know that either it's a factor variable or a numeric variable. You have to let R know what type of variable you have. So it's possible that you have categorical variable and R is treating that variable as a numeric variable. Then you will be in the trouble when you will be doing your data analysis. A factor variable should be a factor variable, and a numeric variable should be treated as a numeric variable. Okay, once again, check again data. So you can plot this gear data. See, so 3, 4, and 5 gears by simply using plot command. Okay, you can also plot transmission, auto or more and manual are less cars. Okay. Now coming to the cross tabulations. So cross tabulation is highly useful if you have 2 categorical variable. If one variable is not categorical or one variable is numeric variable, then you're probably not a good idea to make a cross tabs. All right, so cross tabulations. The command for cross tabulation is very similar to the table command. You just need to put comma and then the name of the other variable. So for example, I want to see the transmission and gear cross tabs. So what if I run this command? See, now I got this results. So from here, I know that auto cars, there are 15 auto cars who have 3 gears, possibly drive, reverse, and neutral could be, yeah. And there are 0 cars who have 3 gears. There are 4 cars who have 4 gears, and there are 8 cars who have 4 gears. All right, and there are 0 cars who have 5 gears, and there are 5 cars who have 5 gears. So this is how the explanation of this one. If you want to make some hypothesis based on your both categorical variable, for example, you want to say there is no dependence on gears and auto, and alternatively you may say the both variables are dependent to each other. So you can make 2 hypotheses. For example, H0, they are independent of each other or no dependence on each other. An alternate hypothesis could be yes, they are dependent on each other, or they are dependent on each other. All right, so for this one, you use chi-square test. Before I apply the chi-square test, you can use the same things again for cylinder. And if you want to see the percentages of this table, you can use again pipe operator and then prop dot table. So let's run this one just to show you. See, now you can see that there is 46%, 12%, 0%, and then manual cars are with the 4 gears are 25%, and with 5 gears are 15%. Okay, so again, I'm going to run the first command with the gear one. So these are the gears, and then auto and manual. So I want to check this one, either there is a significant dependence on each other or not, on one variable to another variable or not. So my one variable is transmission and the second variable is gear. I'm going to copy this command above this one, and just put chi-sq.test, chi-square test in the bracket that I'm going to paste the rest of the command table, then cs $trans, and then cs data $gear. Okay, so just run this command. See, I got the p-values over here. The p-value is the most important one. So x squared, you got 21, df, degree of freedom, you got 22, sorry, only 2, and then p-value, you got 3 e power 0 minus 0.5. It means it's 0.0003. So 3 e power 0.5, so you're gonna bring your decimal 5 places to your left. So it means this is significant. What does it mean? It means you're gonna accept H1. So it means the gears and transmissions are dependent to one another. So there is a relationship between transmission and gear, significant relationship between transmission and gear. Okay, and so at 95% interval, so remember this one. So 95% interval is in, so it means we are considering 0.05 p-value. If the p-value is less than 0.05, it means we are considering 95% of confidence interval. Okay, so what if variable is a numeric variable and the other variable, the second variable is categorical variables. For example, in this case, so we're going to see the MPG and transmission. So there could be a question, very important question, that there is no difference. There is no difference between mileage, mean mileage of transmission. So in simple words, I want to say that if the car is auto or the car is manual, there will be no difference in their mileage. That will be our H0. And alternate hypothesis could be there is a difference between mean mileage of auto and manual cars. How you can test these hypotheses? By simply, before you test this hypothesis, can you please simply test, can you please see first data? So how does it look like? The class of the transmission is vector. Just on this one, you know that class of this variable is vector. And if you want to see, make the table, so let's make a cross tab, then it will look like a messy one. See, it looks like a messy. This is why I said if you make a table between, if you make a cross tab between a categorical variable and a continuous variable or a numerical variable, then it could be a little bit messy. The best way to do it is to use the Boxplot. Boxplot gives you very nice look of one numeric variable and one categorical variable. So just prepare a Boxplot. If you want to see the Boxplot video in detail, please watch my early videos. Okay, so let's make a Boxplot, and then CS data MPG miles per gallon, and then tilde CS data $trans. Let's run this command by hitting Control Enter. And see, it gives you a nice understanding that the auto cars have low mileage and manual cars have high mileage, mean mileage. Okay. Okay, so how you can do it, how you can test the hypothesis in this way, you can use Ttest for this type of uh, hypothesis testing. The Ttest for hypothesis testing, there are two commands. The first one is a little bit not difficult in detail. So Ttest, and then again exactly the copy of the above command, cs data mpg tilde cs data $trans comma. So you want to say mu is equal to 0. It means you make some assumptions that mean is equal to 0. Alternate is two-sided, so you're going to test the two-sided hypothesis, and confidence interval you want to make is 95%. Variance is equal, you say false, and paired, you say false. Variance equals means if both group have equal variance, you say false, it is not, or you can simply put F if you don't want to put false. It will still consider it as false. Both groups are paired. If paired, then you want to say yes, true. Then you want to say true, otherwise false. So if I put only F, then it will work. Just run this command by hitting Control Enter, and see the p-value is 0.01. It's less than 0.05. It means I'm still gonna accept H1, that there is a significant difference between mean mileage of auto and manual cars. Okay, so if you wanna make all these things as default, then the simplest command for testing, applying the Ttest is this one. Ttest, then cs data $mpg, then tilde cs data $trans. You will get the exact same results for Ttest. So let's run this command. See, again 0.001 is the p-value. And then interestingly, see what there in the last line, the mean group, auto mean group is the mean of the auto is 17.1 mileage, and the mean of manual group is 24.4 mileage. Okay, so this is how you can test if you have one categorical variable and one numeric variable. Okay, you can do it with similarly with cylinder. Okay, and now I'm gonna go to what if we have one categorical variable, but that doesn't have two categories. Okay, that have three categories. For example, cylinder. So we know that cylinders have three categories. So let me check this one, that how many categories a cylinder have. I can check it by running this command, table cs data cylinder. Let's run this command. So now I know that there is 11 cars of 4 cylinders, 7 cars of 6 cylinder, and those are 8 cylinders. Okay, so when you want to see visual look of the relationship between MPG and cylinder, go for a boxplot CYL MPG and then tilde CYL. Run this command and see. It shows that 4-cylinder cars have high mean or high mileage, 6-cylinder cars are lower than 4 but higher than 8, and 8-cylinder cars are have lowest mileage than 4 and 6-cylinder cars. So this is a visual representation, and then you want to use the ANOVA in this type of situation. So then when you have cylinder, when you have a categorical variable that have more than 2 categories. Okay, for this one is, so I'm going to remove the below command. So just run this one. This is the name of the output you want to save. You can name whatever you want to, and then assign it to AOV is the name of the command, cs data mpg, and then tilde cs data cyl. Run this one. See, in your environment window, ANOVA results are there. Okay, so call the summary of this one to see into detail. Just say summary, and then ANOVA underscore result. This is the same. This should be the same as you have saved your above results. So run this command. See, this PR value is less than 0.05. It means again there is a significant relationship between cylinder and mpg, miles per gallons. Okay, so here again you should accept H1 hypothesis that there is a significant relationship between cylinder and miles per gallon, just like the last hypothesis. Okay, finally, what if you have both variable as a numeric variable and you want to see the relationship between these two numeric variables? Okay, numeric variables give you actually a linear trend as well, and you can also see the correlation or relationship between two variables. Okay, so for example, miles per gallon is a numeric variable, we know that, and the other variable is weight. That's also a numeric variable. So let's check the class of the weight variable by running str command, this command, str command, and then cs data $WT. So it says numeric variable, rows starts from 1 and it goes to 32. Okay, and one more thing, remember the coefficient of correlations lies between -1 to +1. Okay, so either the coefficient could be -1 or +1 maximum. It should be lie between these -1 to +1. Okay, to test the correlation, the command is core.test and then one numeric variable, comma, other numeric variable, second numeric variable. So let's run this one. See, the p-value is 1 is power -10. It means 0.000000001. There's 10 times 0 and then 9 times 0 and then 1. Okay, so it means it's highly significant. So there is a strong significant relationship between miles per gallon and weight. And is there a positive or negative relationship? So here is your answer of this one. So if COR coefficient is -0.868, it means there is a negative relationship between miles per gallon and WT. What does it mean? It means if you increase the weight of the car, the mileage of the car will reduce. If weight is low, the mileage will increase. You can visualize this one as well by running plot command, plot cs data, comma, cs data WT. See, how does it look like? If you want to make this plot a little bit fancy, you can please refer to my earlier video. You can see that how you can make these plots a little bit more fancy. Okay, so you can do it with your other variables, like HP is also numeric variable. So let's make a graph between miles per gallon and HP, and let's test this one, the relationship between miles per gallon and CS data. So over here I can see that it's a negative relationship, you know. So one variable is increasing and the other variable is decreasing. Okay, so the command is again core.test. It's a Pearson correlation test. And over here you can see that 2 is power -07. It means there are 6 zeros before 2, like 0.000000 and then 2. So it means it's highly significant. So you wanna again accept H1. So there is the H1 is there is a significant relationship between miles per gallon and horsepower. So it means as horsepower increases, the mileage of the car decreases. Okay, and what is the coefficient of correlation? It says -0.776. So this is how you can test the relationship between two factor variables, between one numeric variable, one factor variable, between one numeric variable, one factor variable, and that factor variable have more than 2 categories, and then 2 numeric variables. Okay, if you want to make the line between these two, please refer to my earlier videos. So you can make also a line between these two variables. In next video, I'm going to talk about the simples and multiple regression line, and see you in next week. Thank you very much for watching this video. Thank you.